Welcome to this exciting breakdown of what drives chemical reactions. In this video, we'll dive into the key concepts that explain why chemical reactions occur, including heat, temperature, enthalpy, entropy, Gibbs free energy, and more. Let's get started. First, let's tackle the difference between heat and temperature. Heat is a form of energy. It's the transfer of energy from one object to another due to a temperature difference. On the other hand, temperature is a measure of the average kinetic energy of particles in a substance. To make it simpler, temperature tells us how hot or cold something is, while heat is the energy flow between objects. Different measurement systems are used for temperature worldwide. Kelvin, ideal for scientific standardization. Celsius, commonly used in most countries. Fahrenheit, predominantly used in the United States. Understanding these differences helps us grasp the energy changes in reactions. Enthalpy, represented as delta H, tells us the heat energy change during a reaction. If delta H is negative, the reaction is exothermic. This means heat is released, making the surroundings warmer. If delta H is positive, the reaction is endothermic. This means heat is absorbed, cooling the surroundings. Think of it like a scale of energy transfer. Exothermic reactions release energy as products form, while endothermic reactions require energy input to proceed. Visualizing these changes in energy can help explain why some reactions are spontaneous while others aren't. Let's move on to fuels as an energy source. There are two types of combustion, complete and incomplete. Complete combustion happens when there's enough oxygen, producing CO2 and water. Incomplete combustion occurs when oxygen is limited, creating carbon monoxide, CO, and soot. Fossil fuels, although widely used, are non-renewable and release harmful CO2, contributing to climate change. On the other hand, biofuels, made from recent biomass, are renewable and produce less CO2. Energy content varies between fuels, measured as energy released per gram or mole. Fuel cells are also an efficient technology that converts fuels directly into electricity without combustion. This makes them cleaner and more sustainable. Entropy is a fascinating concept. It measures the degree of disorder or randomness in a system. The second law of thermodynamics tells us that for any spontaneous process, the entropy of the universe must increase. In simple terms, nature loves a mess. It's easier to move from order to chaos than the other way around. Here's an analogy. Imagine scrambling an egg. Once it's mixed, you can't unmix it. That's entropy in action. Now, let us tie everything together with Gibbs free energy. Gibbs free energy tells us the amount of energy in a system that is available to do useful work. The equation for Gibbs free energy is written as delta G equals delta H minus T delta S. In this equation, delta G represents the change in Gibbs free energy. Delta H represents the change in enthalpy, which is the heat energy involved in the reaction. T represents the temperature in Kelvin. Delta S represents the change in entropy, or the degree of disorder in the system. Here is the important part. If delta G is negative, the reaction is spontaneous. This means it can occur on its own without needing an external energy source. If delta G is positive, the reaction is non-spontaneous. This means it needs external energy to proceed. Temperature plays a big role in determining whether a reaction happens or not. Depending on the balance between the enthalpy change and the entropy change, higher or lower temperatures can push the reaction to either occur or stop.